Today I'll discuss relation and some examples of the types of relation. So here definition of the relation is: a relation R from set A to set B is a subset of A cross B, and for the sets A and B should be non-empty sets. Today I will discuss how relation R is related in two sets. So this is the definition: a relation R from set A to set B is a subset of A cross B. A cross B means the Cartesian product of A and B. And this is the necessary condition that your set A and B should be non-empty sets, means there should be something in A and B. So you can write it as, if AB belongs to the relation R, then we say that A is related to B, and we can also write it as A related to B. Here R represents A is related with B, and in case when AB doesn't belong to the relation, then we can say that A is not related to B, and we can write A not related with B. In case when your set A and B are equal, then we say that R belongs to A cross A, or R belongs to the Cartesian product of A and A, is a relation on R. Now let's see example. Suppose you have a set A with elements 1, 2, 3, and you have another set B with elements X, Y, Z. So now if you have taken 1Y, 1Z, 3Y in the relation, we have not taken all the products of A cross B, we have taken few only in this relation. Then you can say that 1 is related with Y, 1 is related with Z, and 3 is related with Y. But you can say in this relation 1 is not related with X, and so on. So I hope that this is clear to you. Now let's see the types of relation. So a relation which are defined on a set A can be reflexive and irreflexive relation, symmetric and anti-symmetric relations, and transitive relations. Now first one is reflexive relation. So a relation R on a set A is reflexive if AA belongs to the relation R for each and every element of set A. Now let's see some examples. Let's consider a set A with the elements 1, 2, 3, 4. Now some relations, I have taken 6 relations. Now you have to check which one of these are reflexive and which one of these are not reflexive. Now let's see in R1. In R1 you have 1, 1, 1, 2, all these. Now check whether it is reflexive or not. So let's see. A contains 1, 2, 3, 4. So 1, for 1 you have a reflexive set. 1, 1 is there. For 2 also 2, 2 is there. For 3 also. For 3 is not there. For 4 you have 4, 4. So you can say that R1 is not reflexive. Why it is not reflexive? Because for 3 there is no 3, 3 in this relation. Now check the next one. R2, only 1, 1 is there. So it is not a reflexive. Check for the R3. 1, 1 there, 2, 2 there, 3, 3 there, 4, 4 is also there. So you can see in R3 you have this AA form is in this relation. So R3 will be reflexive. Check for the fourth one. No 1, 1, no 2, 2, no 3, 3, and no 4, 4. R5, 1, 1 is there, 2, 2 there, 3, 3 there, and 4, 4 is also there. So this will also be reflexive. 6, 3 and 4 is only there. So it is also not reflexive. So now you have understood that among all these, R3 and R5 only are reflexive, because these contains 1, 1, 2, 2, 3, 3, and 4, 4. And R1, R2, R4, R6 are not reflexive, as they not contain these ordered pair for 3, 3. So that's why they are not reflexive. Now let's see the another one, that is symmetric relation. A relation R on a set A is symmetric if whenever A is related with B, then B is also related with A. Now let's see it with example. So here again I've taken A with elements 1, 2, 3, 4. Now there are some relations R1, R2, R3 and R4. So let's see R1. 1, 1 is there. 1, 3 is there. For 1, 3 you can see 3, 1 is also there. For 2, 4, 4, 2 is there. So is this relation symmetric? Yes, this is symmetric. Now check for R2. 1, 1 there, 2, 2 there, 3, 3 there, 4, 4 there. So R2 will be symmetric or not? Yes, it will be also symmetric. Why? Because for 1, 1, you have 1, 1. For 2, 2, you have the same form. Okay. So here, this relation will also be symmetric. Let's see R3. 2, 2 is there, 2, 3 is there, 3, 4 is there. Now see, 2, 3 is there, but for this 2, 3, 3, 2 is not here. For 3, 4, 4, 3 is not there. So R3 is not a symmetric relation. Now for transitive relation, AB is in the relation, BC is also in the relation. So your AC should be there in the relation, then it will be transitive. So if these two are there, then it should be there, then only it will be transitive. Otherwise, it will not be transitive. And now let's see some example of transitive. Now see in this set R1, 1, 1 is there, 1, 2 is there, 1, 3 and 2, 3 all are there. So see 1, 1 and 1, 2 there. So there should be 1, 2 and this is your 1, 2. Now check it for other one. 1, 2 is there, 2, 3 is there. So there should be 1, 3 also. So here you can see 1, 3 is also there. So you can say that R1 is transitive because 1, 1 for 1, 1, 1, 2, 1, 2 is also there. For 1, 2, 2, 3, 1, 3 is also there. So it is transitive. Now let's see for the R2. For R2, 1, 2 is there, 2, 3 is also there. So there should be 1, 3, but 1, 3 is not here. So R2 is not transitive. Now let's see for R3. 2, 1 is there, but 1 something is not here. 2, 4 is there, 4 something is not there. 2, 3 is there, but 3 something, yes, 3 something is there. See here, 2, 3 is there. For this 2, 3, 3, 4 is there. So 2, 4 should be there. So is it here? Yes, it is here. So here you can see that your R3 is also transitive. Next is equivalence relation. So any relation R is said to be equivalence relation if R is reflexive, symmetric and transitive. So for A, for each and every A belonging to set A, there should be A should be related with A. For symmetric, you know that if A is related with B, then B should also be related with A. For transitive, you know, if A is related with B and B is related with C, then there should be A related with C in the relation. So this was all about the relations. I hope this concept is clear now.